I'm very pleased to introduce our speaker today, Niloufar Salehi. She's a Ph.D. student in the CS department at Stanford University, so she hasn't had to travel too far to be with us today. She does research in the areas of social computing and HCI. She builds and evaluates systems that support collaboration at scale, and she draws not only from the techniques and tools of computer science, but from political theory and organizational behavior. She's studied labor organizing, studied and assisted labor organizing among Amazon Mechanical Turk workers, which some really fascinating research. And her publications at some of the premier HCI conferences like CHI and CSCW have been awarded with numerous Best Paper nominations and awards. Please join me in welcoming Niloufar Salehi to the iSchool.
Thank you for the introduction, and thanks for inviting me. So today I want to talk about designing social computing systems that support collective action by centering trust and familiarity. And I'll talk about how these systems can help build strong networks, as well as how they can provide support to move efforts forward when they stall. And I'll explain how I did this work together with accessibility advocates on Mozilla and worker rights advocates on Amazon Mechanical Turk. But I'd like to start this talk with a vignette from an effort that's going on right now and I've been involved in as a participant observer. And it has to do with harassment on Twitter. Yes. Yes. So harassment on Twitter includes things like death and rape threats that are unfortunately very common, and they are frequently used in a concerted way to silence people. And this is an issue that many people have very strong feelings about, and they are determined to act on. And they have taken some actions. So for instance, there's a change.org petition asking to shut down accounts that have tweeted threats, and it has almost 400,000 signatures. And last October, the actress Rose McGowan spoke out against Harvey Weinstein's sexual harassment, and her account was suspended on Twitter. This caused a lot of outrage because there's already a lot of hate speech that even when reported goes unchecked, and then someone who was speaking out against harassment was the one who got shut down. So in response, a couple of people tried to organize a boycott. They chose a hashtag, they picked a date, and they broadcast it through quite a number of high-profile celebrities on Twitter. But the effort itself was controversial. Some people boycotted the boycott. Other people made counter hashtags, such as Women of Color Affirmation. Twitter promised to make changes, but they also said they had limited resources, and the whole effort fizzled. Why? I'm going to argue that there were two main reasons. The first was that there was a lack of trust in the action. So especially among women of color or trans women who felt like they were all of a sudden expected to show up and participate in this boycott, but they had not received similar support when they spoke out about their issues. In one instance, a user said, "If this was the event that activated your awareness, I don't particularly trust you." The second reason was that the effort stalled because there was friction within potential supporters of the effort about tactics, so about whether a boycott was even an appropriate way to protest the silencing of women. And I'll come back to this specific issue with Twitter at the end of my talk, but what I wanted to demonstrate here more generally was that even highly motivated collectives, when facing open-ended complex challenges, often fail to envision shared outcomes and act on them together. And to unpack this a little bit, these groups are very similar to the Deweyan formation of publics used by DeSalvo and LeDantec to talk about groups rallying around shared issues. But what differentiates these particular groups that I'm talking about here is that they're also acting together. So they have to do the work of coordination, collaboration, deciding or even arguing between alternatives, and facing failure. And this is because of the nature of the challenges that they face. These are messy, interdependent, and sometimes even risky challenges that sound a lot like wicked problems. Wicked problems is a phrase that came out of urban planning originally, but it's also frequently used in design thinking to talk about problems that are difficult or impossible to solve because there are too many moving parts, and the problem changes as you try to solve it. And also, this makes the goal and the path to get to it unclear. So what I'm going to propose in this talk is designing to support publics working together on wicked problems. And we know from prior literature that the basis for a group to be able to work on a wicked problem is that they need to know each other and they need to trust one another. Familiarity is a term that I'm going to be using a lot in this talk. It's coming out of social psychology and organizational behavior to describe how well two people know each other. And it's often measured just as how long have they already been working together. And this is really important for collective action because familiar groups know their strengths and weaknesses. They develop situated knowledge of who knows what. And this enables them to strategize and coordinate action. Familiarity can also lead to trust, which increases psychological safety. Groups that have high psychological safety are more comfortable taking risks together. And finally, these groups share knowledge, which can lead to collective sense-making and can lead to the development of a shared identity, which is really important. So we know that for these collectives to be able to act together, they need familiarity and trust. But rather than build that, the existing social infrastructure that we have is designed around increasing these engagement metrics. So it's designed around these atomic, fast-paced interactions. And HCI literature has actually found that the thing that on social media actually increases tie strength is having conversations. But if you think about, for instance, what is rewarded on Twitter, it's these instant likes, retweets, things that get a lot of attention, things that are outrageous or sensational. And so in doing so, the environment itself is incentivizing flyby disagreements and disincentivizing actual difficult conversation. So my main goal is to design alternative environments that scaffold and guide social interactions towards building networks that can help groups form publics and work together on wicked problems that they face. So how are we going to do that? I'm going to show you through two projects that I've worked on during my PhD. The first step is to bring together a group of people to build networks of familiarity. So what we want to do is encourage people to talk to the same small group of people over time so that they get to know each other. But at the same time, we want to balance this with reaching out and having conversations with other people who would bring diverse perspectives. And that's the goal of my first project. It's called HIVE. And I did it in part with accessibility advocates on Mozilla. But even when you have that, efforts can still get stuck. For instance, when disagreements come up. And I've worked on designing structured human support that can move efforts forward when they stall. I'll talk about that in the context of my project DYNAMO, which was a collaboration with worker rights advocates on Amazon Mechanical Turk. And through these two projects, I want to convince you that if we pay particular attention to collectives' relationships of trust, we can design social computing systems that assist that collective in acting together. And these two projects are also going to show a characteristic of my research, which is that I use a range of methodologies to study these questions. So the first project, HIVE, I'll define a model of human behavior, and then I'll design algorithms and build real-world systems. These systems produce new kinds of social arrangements, and I'll study them through experiments that are controlled as well as field deployments. In the second project, DYNAMO, I'm going to take a grounded theory approach, and I'm going to develop concepts out of ethnographic study and co-design. In my research on social system design, I also try as much as possible to collaborate closely with existing collectives. This type of research requires a lot of work, just building trust and showing accountability to the people that I work with. So I'm going to talk about these two projects, and then I'll finish with a discussion and my agenda for future research. So first I'm going to talk about HIVE. And here we're mostly talking about the very early stages of collective action. Here, people are just coming together and they're doing the work of deliberation, understanding and articulating the problem that they're facing, and collectively imagining paths forward to imagined futures. And I'm going to present network rotation, which is a computational method that organizes conversations by balancing how strong people's ties are to the people they're talking to, as well as how tightly knit the network is. So with network rotation overall, what we're trying to do is get people to share ideas, but also to be exposed to different perspectives while keeping psychological safety high. So the way our current social computing infrastructure works is that each person comes out and says the first thing that comes to their mind out into the public sphere. So in the case of harassment on Twitter, one person might think that we should all boycott Twitter for a day. Someone else should think we should actually all share our stories for a day. And another person might think that we should all record abuse, so we should create a list of harassers and have documentation. And these ideas are often very different, and they're also not very good by themselves, because they fail to incorporate other people's viewpoints, experiences, and constraints. And so because of this drawback, HCI literature has looked at different ways to encourage people to engage and intermix their ideas. The way this usually works is that we will create a big gallery or a map of all the ideas out there, and then we're going to encourage people to intermix them. So we might go to the person who came up with the boycott idea and say, here's another idea that someone had, recording abuse. Intermix these two ideas. And oftentimes what happens is that the person who came up with the boycott idea will come back and say, no, my idea was better. And this is because drawing on research in communication theory and organizational behavior, in the real world, mere exposure to other people's ideas doesn't actually influence us that much. We are much more influenced by other people's viewpoints when we talk to them, because knowledge is situated and it's developed in the context of social relations. So instead of intermixing ideas, I propose to intermix people. In one study, researchers found that showing a real-world team that was doing creative work a piece of paper with ideas from another team did not change what they were doing at all. But when they brought another person from that other team and added them to the first team, it actually significantly improved their output on a creative task they were doing. So we know that engaging in conversations with other people can lead to better ideas that dig deeper into the problem. And this is the insight that HIVE is based on, only that we want to be able to do this at scale. So I'm going to propose what I've termed network rotation. So instead of having everyone talk to everyone, it's going to instead divide people into smaller teams where they can actually have conversations and get to know each other. And then it's going to iteratively weave people together from distant parts of the collaboration network to facilitate the spread of viewpoints within the collective. Now, there are many, many different ways to reorganize a network, and HIVE wants to do this intelligently. So we need to know what the conditions are for effective network rotation. One of them is familiarity. Familiarity increases psychological safety, and it's really important for us to be able to do work together. And I've actually done research looking at using a dynamic programming algorithm to optimize for highly familiar teammates when we didn't know individual availability of people online. But the challenge of that work is that we also want people to engage with diverse perspectives. So we don't want you to always talk to the same small group of people. And I'm going to hypothesize that balancing these two needs is actually going to be more effective than strategizing to maximize either. And I'm going to show you how network rotation does that. It balances familiarity, measured as tie strength, with the structure of the network, which we measure as network efficiency. And I'm going to talk more about it. And then I'm going to talk about two deployments that we did, which showed that network rotation caused teams to submit better proposals. It didn't reduce psychological safety, and it was also used by Mozilla accessibility advocates for a week-long design drive. So first I'll talk about HIVE's network rotation algorithm and how it works. So again, my core technical contribution in this paper is going to be this concept of network rotation that manages team membership. I'll walk you through what that would look like in practice. So when you first join a project on HIVE, the algorithm will add you to a small team of 3 to 4 other people. And it was really important for me to be able for the system to be usable in the real world, so we decided to use a chat software that people were already familiar with. So HIVE works as a Slack app. This also gives people the option to remain anonymous in these teams. So based on the team that the algorithm assigned you to, HIVE will automatically add you to a Slack channel for that team, and you'll start working with them. Then at some point, HIVE will decide to expose your team to a different viewpoint. So it'll swap out a teammate for someone new. And the way that it does this in practice is that we have a Slack bot that will come to your team. It will announce that so-and-so is leaving and another person is joining, and then it will actually administer the change. So now you have a new team, and you continue to work with them. And by the end of the day, the algorithm might decide to do another round of rotations. And as you can see here, there are many different ways to do these rotations. And it gets even more complicated when you have more than just 4 teams. And so to do this, the network rotation algorithms needs to decide when to make rotations, who to move, and where to move them to. And as I said, there are an exponentially large number of possible ways to do this. So we model the collective as a weighted graph. And the 2 things that we care about in this graph are tie strength, which is how familiar are people who are on the same team. So imagine that this is the network that we have. These are the teams that we have. We care about tie strength between people who are on the same team. The other thing that we really care about is the structure of the network. So it's not just that you're talking to people you know well, but it's also who and in what part of the network are you talking to next. And this is a measure, so we measure how closely knit the network is. What we want to be able to measure is the difference between these 2 networks, where in one you have these silos and bridges between them, and in the other one, people are pretty well connected. So a lot of people might directly know each other, or they might have common people who they know. And the way that we measure this is if you take 2 random nodes and calculate what's the shortest path between them. You see that in a well-connected network, it's smaller than in the other one. And so if you want to see this over the whole network, all you have to do is average it over all of the pairs of nodes in that network. So given these 2 metrics, we want to balance them. And the way to do that is with an optimization function. So the optimization function tries to optimize for the sum of tie strength and network efficiency. We can also make it a weighted sum, and that way we'll have a little bit more leverage in saying how much each of these matter. So in this specific instance, if we set alpha to 0, what that's going to mean is that I don't care about tie strength. If we set alpha to 1, what that's going to mean is that I really care about tie strength. I don't care about the structure of the network at all. And what's going to happen is that there's going to be no reason to move anyone, because it's always better to stay with the people you know. And you'll get a network where everyone is really well connected to a couple people, but not overall. If you set alpha to 0, on the other hand, it's going to mean I don't care about tie strength, I really care about efficiency. And so the algorithm will be constantly moving people around. It'll result in a very well-connected network, but most of the time people will be talking to strangers. And our algorithm tries to balance these 2. So now that we know what the objective function is, how does the algorithm work? So as I said, the algorithm needs to decide at each point who to move, if any, and then it needs to decide where to move them to. So one way to do this would be take 1 random move and see how valuable it is. So we might take this 1 move, moving someone from team 1 to team 2, actually administer the move and see what happens to the network. How much added benefit do we get? And this was easy. But we don't want to do just 1 move. We want to do more. So we might take another random move and say, what about this one? The problem with doing the same thing again is going to be that if we make this move, the first value that we calculated will no longer be valid, because we calculated that benefit with a certain assumption about who's going to be in team 2, which is not the case anymore. And that's what makes this problem really hard. There are an exponential number of possible solutions, and team composition keeps changing, so it's impossible to know the value of a single move. And so I proposed a stochastic search algorithm to solve this problem. It chooses the best subset of moves using a stochastic search. What that means is that it takes a solution that it has right now and it thinks is the best possible solution, and it takes a random move and sees whether adding this move to the solution would make it any better. All it needs to do is actually add that move to the solution. Now it has 2 solutions, and it can compare, and it'll take the best one. And so it keeps doing this, and with a random chance every now and then, it'll restart so that it doesn't get stuck in local maximum. So that's the algorithm. Yep. So I'm hypothesizing that this objective function is going to be better than alternatives. And then I'm going to run an experiment to see whether that's actually the case. Yes, I'm varying alpha. Yeah. So that's how the algorithm network rotation works. HIVE, the actual system, is, as I mentioned, a Slack app. It manages team membership, but it can also provide structure to the conversation. So in our deployments, we followed 1 iteration of the design thinking process. And this helped guide people through the conversations and what the goals of each phase are. So as I mentioned, our goal with HIVE is to organize conversations. And we hypothesize that this will lead to more effective collective action. And the first thing we wanted to do was to see what the effect of network rotation is. So if we can control as much as possible, can we study this? And so we recruited 115 Amazon Mechanical Turk workers, and we asked them to design neighborhood commons to be a place to foster community and mutual aid. And what we specifically told them was that if your neighborhood is given a space roughly the size of an elementary school playground, what could you do with it? And we tried to choose a prompt that a lot of people had experience with and could relate to, and we also gave them rubrics that we took from OpenIDEO for what we wanted them to do. And then we randomly assigned people to 3 conditions. The control condition is when alpha was set to 1, meaning maximized high strength, and this is the condition where no one moves, everyone stays with the same team. The second condition was network rotation, which was our algorithm, and the third condition was alpha set to 0, which means maximize network efficiency, but don't care about high strength. And so teams went through 5 phases of the design process in 2 days. And we wanted to measure how well the teams did. So we hired a design expert to rate the proposals that the teams had submitted at the end based on the rubric. And what we found was that network rotation improved over the baseline, but network efficiency did not. So about 60% of the top third of proposals were submitted in the network rotation condition. But we still worried that moving people around might make people less comfortable in contributing, and this might make the whole experience too disruptive. So we looked at whether psychological safety was hurt when we did this. Psychological safety is a measure of the perceived ability to take risks in a team, and it has strong correlation with team performance. It's a standard survey, and it has questions such as, members of this team are able to bring up problems and tough issues, or working with members of this team, my unique skills and talents are valued and utilized. And so this gives us a score out of 50. So after every phase that people completed, we gave them the survey to complete once. And what we wanted to see was that whether this measure was hurt when people were changing their teams. What we found was that looking at people who had been in static teams or people who had been in teams that had changed, the psychological safety score didn't go down. But there is one group of people who are not in this graph, and those are the people who are actually moving. So this is about 10 to 25% of the population. And we found that for them, the score did go slightly down, especially in the later days as people became attached to their teams and their ideas. It became more difficult for people to move and reintegrate into another team. And what this shows is that these rotations are costly, and so it's important to do them in an effective way. So with the control experiment, we showed that network rotation was really effective. But we still wanted to know whether people would actually do this in the real world. So we partnered up with Mozilla's Open Innovation team. And they issued an open call to their communities of volunteers and accessibility enthusiasts, asking them to participate in a week-long design drive, reimagining what it would look like to have an accessible web browsing experience. They also reached out specifically to people with disabilities and offered them a $150 gift card for lending their expertise to the project. We wanted this to be very grounded in people's real experiences. We also made the people who had joined in that way team leads, so there was one of those people per team. One of the really interesting things about this was that even though this was a week-long online effort, there was very little attrition. So out of the 105 people who originally signed up, only 6 people dropped out, and everyone else completed it. On average, each team posted about 1,000 lines of chat per day. And to give you a sense of the kinds of proposals that people submitted, I'm going to show you 2. So one was about ways of interacting with the computer similar to sign language. In this case, one member in the team actually knew sign language, and they were talking about how in communities of people who sign, they are constantly reconfiguring gestures to mean new things. And these people wanted a way to be able to teach the computer what these specific new gestures mean. So for instance, a gesture that means send an email to my best friend, or what if nodding my head meant save the document. Another proposal was about reactive interfaces. So these are interfaces that track and understand when you're having trouble interacting with them and react. So for instance, if I'm having trouble clicking on a button a couple times, it might increase the size of that button for me. And these proposals were all reviewed by the Mozilla accessibility team, and they chose 5 that they were really interested in moving forward with, and they gave feedback on all the other designs. So I want to talk now briefly about what we learned through doing this process. We learned that participants told us that new members brought fresh perspectives, and they allowed for more ideas to come into the room. One person said, meeting new people was great. Mixing ideas was really helpful, especially as people dropped in and out later in the week. And while fresh perspectives were exciting and helpful, people also showed concern about losing on ties that they had already built with their old team members. So one person said, I liked bringing in fresh ideas every day. It gave a different or new perspective. But sometimes you build good working relationships with people and you don't want to lose them. So this result demonstrates again that it's really important to balance tie strength with network efficiency. And one way to mitigate this might be to give teams more control over when these rotations happen or not. Another thing we learned is that the anonymity that this space provided made people more comfortable in sharing their stories. So one person who actually had disabilities said, wow, that didn't even feel like an hour. I'm loving this. This is stuff I never talk about. It's helping me realize some things about myself that I was blind to before I started talking about it here. Thank you all. So in a way, our alternative environment increased psychological safety by providing a space of trust and anonymity. So with HIVE, I just demonstrated that it's possible to create environments for collectives to come together, build familiarity, and generate plans and proposals. And HIVE was designed for groups who didn't know each other yet. DYNAMO, in contrast, was designed for people who did know each other, and in some ways, familiarity was contributing to the problem. And this was a problem that we couldn't formulate and design an algorithm for. In fact, I'm going to argue that the kinds of work that it required cannot be written into code. And so instead, we're going to need to use structured human labor. And in this part of the talk, I'm going to move from a very algorithmic heavy section to a section that's rooted in qualitative work and participatory design. And to present DYNAMO, I'm going to go back to the argument that I made at the very beginning of the talk, which was that many collective action efforts online never succeed, and why. And we already went through one of the reasons why that might happen, which was a lack of trust and familiarity. But friction can still happen. The collective that we worked with here, the Amazon Mechanical Turk workers, consisted of multiple tightly knit communities that had experienced disagreements and animosity in the past. They even had a name for it in their community of practice. They called it megadrama. And with DYNAMO, we were trying to see how can we support collective efforts despite these problems. And this is a really highly context-dependent problem, so I took an ethnographic approach. I engaged with Mechanical Turk workers and the communities that they had through a year of fieldwork. And this helped deepen my understanding of their work environment and the challenges that they face. And it also helped build a working relationship with them that we used to create DYNAMO. I'm going to start this section by talking about the challenges of online work. So what were the issues that these people faced? And then I'm going to talk about our effort to address them, DYNAMO. And then I'll explain the common failure scenarios that they faced and the specific kinds of organizing and emotional labor that it took to lead them to success, what I call the labor of action. And I'm going to explain its mechanisms in more detail. So researchers have argued that crowdsourcing platforms are these computational infrastructures that make crowd workers seem invisible. And as a result, a whole online labor market has emerged that leaves many workers struggling to find good work and to assert their rights when they're mistreated. And in response, Turkers have formed collectives using web forums and chat software that they use to share good work, educate newcomers, talk to employers, or even raise money for another Turker in need. And what I found was that these forums were more effective at coordinating action when the effort was not controversial and when individual actions still had an effect. But they struggled more when the goal or how to get to it wasn't very clear and required debate, or when many hands were needed to share the burden. What I found was that Turkers did talk a lot about these issues that they faced, but they had trouble taking the next step. And this is the same essential challenge as Twitter users were facing when they were having friction over tactics, and this caused the whole effort to fizzle. So how can we support an online collective, not just to talk about issues, but also to agree on a common goal and execute it? And our effort to address this question was DYNAMO. Our process for designing DYNAMO was interactive and iterative. It involved overall almost 100 people. And it's an online platform that supports Amazon Mechanical Turk workers to form collectives around shared issues and mobilize. And to show you how it works, I'll walk you through one example. This was triggered by an incident by a well-meaning researcher who injected false information into Turkopticon, which is a Turker reviewing system. This caused a lot of frustration among Turkers because they relied on the accuracy of that information for their jobs. And this frustration also came out of them having to spend a lot of time researching and trying to figure out what had even happened. So by the end of this, Turkers agreed that researchers lacked exposure to the kinds of issues and vulnerabilities that they faced as Turkers. And this prompted them to want to write a set of publicly available ethical guidelines for research on Amazon Mechanical Turk and its communities. They thought that these ethical guidelines could be both a means to guide ethical behavior, but also to back Turker claims when things go wrong. But there was a big gap from wanting ethical guidelines to actually writing them and agreeing on them. And so I'll go over the socio-technical infrastructure that we made for this. We had very short ideas that made the path to entry easy, and people could vote on them and discuss them on a forum. Once an idea had 25 upvotes, and it had more upvotes than downvotes, it evolved into a campaign and officially launched on the platform. So by creating these ideas, voting on them, and discussing them online, DYNAMO was supporting these collectives to form what is known as publics around shared issues and mobilize. Publics often come together around shared issues that they face, and they develop formulations and analyses of the problem. And much of the research on publics so far has focused on these conditions for discourse and assembly. And I build heavily on this work, but I'm also taking up the conditions by which these publics can successfully act together on shared issues. And when shifting from deliberation to action, DYNAMO efforts almost failed, multiple times. The two common failure scenarios that they faced were stalling and friction. And these are common pitfalls that any online action can fall into, because the same decentralized characteristics that make it really easy to gather online also make it easy to disperse. It's very easy, in other words, to walk in and throw a flame. It's also very easy to leave. And so stalling was one of those failure scenarios. This was often when an effort lost momentum and stopped. And this often happened because the next steps to take were difficult to identify, or it was just too much work for an individual to accomplish. So for instance, one effort on DYNAMO was a letter writing campaign that stalled. So after weeks of discussion, one Turker who was leading the effort and was a community manager of a Turker forum contacted us and said, "So it seems no one is interested." At this point, 6 people had written their letters and shared them. They said, "A Turker just says we're doing it wrong, but won't say how to do it right, and no one else has input." But stalling was still in many ways better than friction, which was when there was active criticism and negative emotion targeted at the effort's progress. So the guidelines effort that I mentioned faced friction. Halfway through writing the guidelines, one Turker expressed disappointment about a certain paragraph in the guidelines that was not technically in compliance with Amazon's terms of service. So this was a paragraph that was offering guidance about how to use a specific kind of screen reading software that a lot of social psychologists use, but was technically against the terms of service. This Turker critiqued this position that the document had taken and also had general critiques that the document had gotten mired in technical detail when it was supposed to be a high-level document of ethics. So stalling and friction are twin pitfalls, and I'm going to argue that they are inherent challenges for online communities that act. To avoid stalling, members need to act, but acting can backfire if other people disagree, causing friction. And to address friction reduces motivation in the people who are getting critiqued, causing stalling. And so in other words, trying to fix one of these problems often causes the other. And so it seems that online collectives have far more reasons to fail at acting together than they do to succeed. When DYNAMO actions faced these pitfalls, we stepped in. and we performed the kind of labor that was necessary to preserve the forward motion of the movement. We call this the labor of action. So the way this worked is that as issues came up on DYNAMO, we worked with people to help them move past it. And gradually, we found that there were these common mechanisms that we were repeatedly using that we could draw out and name, and we could transfer them even to other contexts. And my main contribution here is the labor of action, which includes particular kinds of emotional and cognitive labor. I'm gonna describe two of these mechanisms. So the first was debates with deadlines. When friction happened over that one paragraph in the guidelines, the disagreement quickly turned into a heated debate that derailed the whole conversation about the guidelines. And here our role was to step in and give members a reason to find common ground. So the specific way we implemented this is that I stepped in and I said, we've spent so much time and energy on this, we need a last effort to reach consensus, and we need your help for that to happen. Do you think that setting a deadline would help? And one of the sides of the argument responded with, I do agree we should wrap things up soon, if possible without unnecessary sacrifices. So the goal with debates with deadlines is to set a deadline, giving people a reason to find common ground. And once people agree on that deadline, then they will work together. The second labor is act and undo. So as we approached the deadline for the guidelines to be published, there was one section that no one had touched. And that section was titled, What to Do in Cases of Violations. So we stepped in here and we drafted 3 emails in the form of templates that Turkers could use to contact researchers or IRBs in cases of violation. And this started a heated debate. Some people felt like the way that we had framed this was restricting. One person who was actually leading the guideline effort said that the purpose of DYNAMO should be to add to the rights and recourses of Turkers, not to limit or replace them. But our action got the effort moving. So after some discussion and editing, Turkers were satisfied with the final result. And we call this act and undo because what we're proposing is to take action, but to leave space for objections and undo your action if necessary. And the point here wasn't for us to do something right, but to do something, even if it was initially perceived as wrong. This kickstarts inertia because people are a lot better at pointing out what's wrong with something or improving something that's bad than they are at putting out a proposal in the first place. There are 2 more mechanisms that I'm happy to talk about later, but now I want to ask, did these mechanisms actually help? And I'm going to talk about 2 efforts on DYNAMO that did succeed. So after over about a month of work, Turkers finally published the ethical guidelines on September 7th, 2014, which was Labor Day. The guidelines themselves are available online as a 23-page write-up at this URL, and they cover things like fair payment and respecting Turker privacy. It has 261 signatures so far by researchers and Turkers. We've also seen it referenced in tasks on Mechanical Turk in academic papers, and the Stanford IRB now uses it to approve research. Another group on DYNAMO started a collective effort to show the world who Turkers are, written from their own perspective. And this was in response to a lot of the media narrative at the time that was talking about digital sweatshops and low-skilled workers. And so they wanted to put out their perspectives. And they started an open letter writing campaign to Jeff Bezos, Amazon's CEO. 30 people posted their letters publicly that you can read at this URL. And it was covered by major news outlets, including The Guardian and The Daily Beast. Since then, Turkers have gotten action on 2 of the things that they had asked for in the letters. One was direct payment to Indian Turkers. So to conclude, DYNAMO was about how structured labor, the labor of action, can help these movements overcome the challenges of stalling and friction. And what's central here is the fact that the labor of action cannot be written into code, because it requires contextual knowledge and familiarity of the members of the public and what their goals are. It's also risky sometimes, so it requires an identified, trustworthy actor to carry it out. And I think this challenges the idea that social software by itself might produce the conditions for social change. And I would encourage us instead to think about the kinds of labor that can combine with software, and how can we better support those labors. For the past few months, I've been advising a nonprofit called coworker.org It's a platform developer for worker collective action, and they're interested in launching and maintaining DYNAMO as an anonymous, moderated platform for worker advocacy. In this case, they actually have employees with knowledge of labor law who could do that work, and some of the open questions are, how can we train people to perform the labor of action, and what kind of tools would be helpful for them in doing that work? And given that Coworker has worked with and won cases for workers at a number of large organizations, including Starbucks, I think that DYNAMO has real potential here to open avenues for more worker advocacy. And so to conclude, in this talk, I argued that to support publics working on wicked problems collectively, we will need to design social computing systems that center trust and familiarity. And through DYNAMO and HIVE, I demonstrated that human labor and computational models are both important parts of socio-technical systems. Thinking back about the Twitter example and other collective action challenges, it's important to note here that collective action is hard. It's complicated and it has many different aspects. And my projects try to provide a step in what I believe is the right direction in supporting that kind of work. For instance, HIVE provides patterns for how to build familiar networks when people don't know each other yet. And DYNAMO provides patterns for working with disagreements and preserving momentum. But they have limitations. So HIVE can help people who are willing to talk. But if they aren't willing to talk, there's not much that we can do. And disagreements can actually be very helpful. And DYNAMO and the labor of action can help move efforts forward when they happen. But not if things have completely derailed. And there's still a lot more work to do in this area. Some other aspects of collective action include making shared decisions, gathering and sharing information, creating shared identity, and supporting peripheral participation. And I plan to continue working on these questions in the future. Here I'll dive a little bit more in two of them. So one area that I'm interested in pursuing more is thinking about making shared decisions democratically. And one of the areas of future research that I'm really excited about is engaging with theories of democracy that I've been reading as part of a multi-campus UC group, thinking about things like rational public sphere and agonism to study both the question of what is social computing's role in supporting or derailing democracy, and how can these theories inspire innovative new models for social computing to support democratic decision-making. And going back to the problem of harassment on Twitter, I've started research with a collective called Buy Twitter. Their ultimate goal is to buy Twitter and run it as a user-owned co-op, democratically governed by its users and engineers and workers. And they believe that the issues that highly affect users on Twitter, such as harassment, will only be effectively addressed then. But how can a collective as large as Twitter users engage in democratic governance? In a traditional and liberal understanding of democracy, we can think of the Twitter effort and frame it as a negotiation between different interests. And this is how I think Habermas would look at the problem. And this immediately brings up the question of what about the voices of trans people who had to leave Twitter because they were getting harassed? And Nancy Fraser's critique of subaltern counterpublics provides a helpful framing for thinking about that problem. One research project that I've just started with this group is thinking about, as a practice of democratic governance, putting together a code of conduct that is user-authored for Twitter. And incorporating the diverse viewpoints of the people in the collective and getting them to agree on something engages with a lot of the same questions that I brought up. The second area of research that I'm really excited about is gathering and sharing information. I'm interested in designing tools for collectives to ask questions that they care about and to gather and research their own data about it. So there's already a long precedent of citizens individually gathering data for research, but community-led research with the goal of gathering and integrating data to research challenges that the community faces is still widely out of reach. And this challenge can benefit from some of the patterns that I talked about today, such as creating familiar networks and helping move efforts forward when they stall. But it also introduces a new question, which is how to gather and share information collectively. And I've started conversations with some Uber drivers who are interested in gathering their work history data to research questions such as what is the effect of surge pricing on my income or price cuts. So the open questions here are how might communities work together to define what data they need and to strategize about how to gather it? How can we design computational systems that assist in gathering that kind of data that could be potentially sensitive while preserving the safety of the people involved? So I just went over 2 of the areas of future research that I'm interested in working about. And I'd like to conclude by thanking my advisor, Michael Bernstein, and my committee members, Lily Irani and James Lande, and the amazing researchers that I've been fortunate to collaborate with, and the students that I've been able to mentor. I look forward to your questions. Thank you.
Mechanical Turkers or for the Mozilla accessibility improvement, it seems that these were not very contentious topics, or that the interest of all the actors were rather aligned. How do you think that your research would apply to situation where there is like more difference in the interest or more contentious topics?
Thank you. Do I need to repeat the question? Oh, you can just okay. That's a really good question. I think that the way that the literature that I'm building on here is thinking about ways that people with shared issues can come together and act on those issues. So you're right in the sense that these people have aligned interests, and that's what's bringing them together to act collectively. The kinds of problems that I'm looking at right now is they do have differences of opinion, and then they have shared interests, and how can they come together and act on those shared interests? There's another question of when you have a large collective, say all the people in a country or all the people on a certain platform, how can they negotiate their interests? And there are different theories to think about that, but one way to think about it is that people will gather around problems that they face and act on them, and that's how a democracy will function. There are other ways of thinking about it too that I'm happy to talk about more later. Yep.
Hi, Niloufar. Thank you for the talk. And I think this combination of algorithmic work you showed, but also deeply grounded work resonates very much here at Berkeley. One question, the examples you showed for HIVE and DYNAMO, right? These are socially desirable goals to work towards, increasing accessibility on the web, developing ethics guidelines, but we're also in a particular moment where we're very aware of online collectives working towards undermining democratic ideals. And so would your tools similarly make those groups more effective, or is there a way to embed social values we might have into the tools as well?
Thank you for asking that. I think that's an excellent thing to think about. So the way I think about it is that at some point in history, we decided that it would be good for everyone to be able to talk to everyone else at very low costs. And I'm building off of the assumption that that's not going to go away anytime soon unless we turn off the internet. So what I'm trying to do is, given that people do have access to each other and they can organize around issues, whether we think that they are socially positive or not, how can we build tools that would help people with shared issues act collectively? And of course, some of those issues might be things that we don't agree with. Can we build socially desirable things into technology? I think that we can try. One way that I try to do that is choose issues that I think are socially valuable and work with people on them. And of course, any kind of technology can be co-opted in ways that we can't even imagine. And I'm fully aware of that. But at the same time, I think it's valuable to create counter forces because those forces are going to be there anyway. We have social media. We have all sorts of different ways for people to come together around issues. The other thing that I care about is that collective action is usually more beneficial to people who are in lower power. One of the ways that we act when we don't have enough power is that we find other people who have similar issues and we try to put our forces together. And so that's another way that I think that collective action could have a potentially positive impact. And of course, it could still be used by people who I don't politically agree with.
It's kind of directly related to this. I'm wondering about just visibility, right? That organizing collective action, particularly from the bottom up or from the outside in, tends to benefit or has traditionally tended to benefit from some ability to control who has access to what's happening. And you talked about kind of the extent to which people valued pseudonymous participation, but even just like increasing the visibility of organizing activity often invites counter activities by people with much more power. So I'm just wondering if you could talk a little bit about kind of the politics of visibility and how that might play out here.
I'm really glad you asked that question. I actually think a lot about accessibility. For instance, with DYNAMO, I was working with Mechanical Turk workers who, for them, time spent at the computer online was time that they should be making money. And so it was really hard for them to go out and have long conversations with other people about the ethics of research. And so I think a lot about the ways that the particular groups and the kinds of vulnerabilities that they face, how can we make this even more accessible or easier for them to join? So for instance, on DYNAMO, we made avenues for people to be able to quickly participate and leave, such as voting. In some cases, you want anonymous participation because people fear for their employment. This was the case with Mechanical Turk, and actually we created a pseudonymous approved method for people to join the platform that made sure that every person could only get one account, and everyone had a synonymous name that was in the format of adjective plus animal. And so these are very context dependent. You have to look at, so for instance, I was like Dragonfly. These are very context dependent. You need to look at what is these people's social situation and how can we develop systems that are accessible to them. The same goes for the accessibility advocates. Some people wanted to talk about their disabilities, and so it was important to be anonymous in that case. So I try to use these different design interventions to make sure that as much as possible things are accessible. The other part of your question was about visibility of advocacy or organizing. I actually think that systems such as HIVE can produce some much needed unvisibility, because when you're having this conversation about what are we going to do about harassment, and you're doing it publicly on Twitter where everyone can see, this can make the people who are advocating for it really vulnerable to attacks. And so creating these counter environments or other types of environments where people can leave the dominant platform, go to another place where they are anonymous and they can actually have conversations in a safe environment with other people who share those issues, and they can create formulates of the problem and plans of action is, I think, a good way to counter that.
I was going to follow up on Deirdre's question about the politics. I mean, if you play this out and think about your next project on democratic deliberation, you're going to run into more political conflict than you've seen in these sort of groups that are have shared interests. How do you anticipate being able to address that? That's a very open-ended question.
Yeah. I think it's completely true, and something that I've been thinking a lot about working with this group. I think that the way I address this for myself in my own research is that I try to find groups that I mostly agree with or think that they are in a pro-social or politically positive way what they are doing, and I try to help by creating systems that I think would support that. And of course, at some point I might see that, oh, this is going in a direction that I completely disagree with, and my option there would be to exit. But most of the time, the way I invariably insert my own politics is by choosing groups who I think would be good to help. I think DYNAMO was very much about that. We stepped in and we were researchers and we had stakes involved. As an HCI researcher, I was part of a large group of researchers who were using Mechanical Turk. And at the same time, there were these various groups of Turkers. Mostly what we did was, as much as possible, try to reflect and propose solutions when conflicts came up, but that's not always possible. In the case of DYNAMO, it was to an extent of getting them to succeed in the goal that they were trying to succeed in. Yeah, of course, it's definitely hard to scale, and one researcher working with a big community is very difficult to scale.
Thank you for the talk. During our conversation earlier, you mentioned that with HIVE, there was a kind of a co-design process or a participatory element, particularly that was focused on the needs of the community. I'm wondering if you can talk a little bit more about that aspect.
Yeah, I'd love to. So the way this worked is that we initially ran an experiment on Mechanical Turk. We used a lot of, for the kind of process that people were going through, we used a material about design thinking and what the goals of each step are, empathizing, defining the problem. And then we went and we wanted to work with these accessibility advocates. And when I tried to use the same material, I noticed that it wasn't really easy to use it, because a lot of the language that we use often in design, such as empathize with the person you're designing with. Once that person is part of the team that is designing, and especially if they're in a vulnerable position, such as they have a disability, it becomes really hard to use that language. And so part of the process was actually going through that material and rewriting it and changing it in ways that would make it possible to work with that community. And I'm sad that I didn't get to talk more about that part in the talk, because I wanted to concentrate more on the technical aspects of that project. But I definitely love to talk more about it later.
Again, thank you for a very interesting talk. And I think you've done a very nice job of distinguishing two distinct cases that need different kinds of intervention. But built into that in some way is the notion of your intervention, very insightful. But do you see a way in which groups can, in some self-diagnose and therefore see which way to turn, rather than have to wait for the intervention of someone like yourself to come in?
Yeah, so I think that what I'm trying to do here is produce language and knowledge about how to do this work. It's not necessarily that I would have to be involved in doing the actual work. So for instance, part of my role as advising coworker.org is that they are trying to produce the same kinds of patterns that we use with DYNAMO, but in other contexts and with different kinds of groups. And so a lot of the role that I see for myself as a researcher is creating design patterns and understandings of, in this new kind of world of collective action using the internet, what could go wrong and what are ways that we could mitigate those.
Thanks for the talk. This is in some ways an intersection of Paul's question and Mark's question. I guess he left. But in the context of HIVE, I guess I'm curious about this alpha. And so, you know, there's a lot of literature in management science that I don't pretend to be very familiar with, but that sort of looks at the optimal structure of teams. And someone might know more than this about me, but my takeaway is that, like, sort of the diversity, homogeneity trade-off, the level that's optimal, it really depends, right? It really depends on the task. It depends on how heterogeneous the people are, and it depends on sort of the intersection of the two. And so I guess I was a little surprised that you framed the contribution of HIVE around sort of the balance rather than sort of a framework for thinking about, like, where on the spectrum to fall. But I mean, I think that that's an important contribution. And I guess I would like to hear you riff a little bit more about, like, how general you think your finding is, and sort of in the spirit of Paul's question, like, absent an organization's ability to do an experiment to figure out what alpha is, how to think about, like, what they should do.
You're completely right that what we want or where alpha should be really depends on what the task is and what the context is. And that's another part of HIVE that I didn't get to go into. Here, the context was that people who didn't know each other were coming together to work on this design project. And based on a lot of prototypes and testing that we did before with different groups, we found out that it was really difficult to have more membership changes than about once a day. So the exact value of alpha that we set was such that that would be what was happening on average. So it was very socially situated and context dependent based on the groups that we were working with and the environment they were in. They were in these chat rooms with 3 to 4 other people. So I think the contribution is mostly about the fact that what at a very high level I care about is just thinking about social computing and communication as this thing that relies on our social relationships, not just on the specific abstract information that we want to transport to each other. And so one way of thinking about that is how much can we model how well two people know each other, and how diverse someone's perspective might be from the current group. So the contribution is really that here's one thing that works better than either of those two other ones. And in different contexts, you might want to set different settings for alpha, and you can do much more research to figure out in what context you want that, in what context you want more of it, in what context you want less of it. But I think I'm just taking a first step here in creating that framework of thinking about social communication. Did that answer your question?
Sure.
Yeah, thanks for the talk. I was also going to ask about the HIVE work, and I noticed at the start you had, you were contrasting keeping the groups small and connected versus connecting people from across the network, but linking it to your other point about some people harassing others online and maybe your social justice sorts of interests. A lot of people want to avoid certain others online, and I didn't really see a way in your algorithm to keep, say, people apart that should be, and that didn't really seem to factor in there. So, like, I'm sure there's certain individuals that are separate right now for a reason. So how might that factor into your larger scheme of things?
I'm really glad you asked that. The thing about HIVE is that I'm not proposing that this is the best kind of social computing system. I'm talking about how this can be a pattern for a specific kind of problem in social computing. So I don't think that it would be helpful to have all of Twitter be in a HIVE system and then have people from really different ways of thinking and different social situations have to talk to each other. But this is for a specific kind of scenario where you have a group of people, they have a shared issue, and they have a commitment to talking about that issue and thinking about plans of action around it. In that scenario, it's really helpful for people to talk to people who might think very differently about the same issue. And that may end up in people figuring out that there's no way that they can work with this collective. And that can actually be a good thing. Not all collective actions have to lead somewhere. But what we're trying to do here is take a group of people who don't really know each other and make them more cohesive and make them hear each other's thoughts and create shared understandings of an issue that they face. And this works better when you have a group of people who are more or less facing the same issue, have some shared understandings, and have some commitment to talking.
Well, I guess I was referring to the slide you had earlier where there was people that really did know each other. There were local connections and then more distant connections. And sometimes people that are in the same organization, say, very carefully structure their lives to try to keep some distant connections without making it very explicit. And I think this sort of algorithm sort of destroys those delicate relationships, those delicate arrangements that people make sometimes. So it's kind of interesting that when you take an algorithmic approach like this, you sometimes obviate those careful social structures that people build.
I agree that the specific ways that a system would work is really dependent on the context. You're right that in an organizational setting, it might be good for people who might deliberately want to stay away from other people. In this case, we're talking about people who don't know each other at all, so they're just starting off. So there's no real reason why we would initially deliberately want to do this. Later on, when people do have conversations, things can go wrong. One person might feel like they're being consistently dismissed by a group and they want to keep their distance. And in other research that I did, which was specifically trying to maximize familiarity in a team, we had this option where after every project that you worked on, you could rate each person that you had worked on based on this person was okay, I enjoyed working with them, I really, really like working with this person, and I don't want to work with this person again. And so we would actually create negative links between people so that they wouldn't have to work together. And again, that was specific to that context where people were working on creative tasks together over weeks, and sometimes the work didn't go very well. So a lot of my social computing design is situated within groups of people and what they're trying to do at that point.
Thanks. So there seems to be a theme to some of the questions with regard to HIVE around, maybe in reaction to what is a kind of very general objective function, right, of efficiency and ties. And so I'm also going to ask about kind of domain adaptation or adaptation to knowing more prior knowledge about the individuals involved. So if you did have prior information about, let's say, complementary skills or knowledge or understandings or structures that the individuals in the network, albeit still strangers to one another, have, how might you integrate that information into the algorithm?
So in our deployment with Mozilla, we did this a little bit because we had people who had disabilities and we wanted them to at least have people on each team. So we just configured the algorithm so that it wouldn't move those specific people. But thinking about even more metadata that you might have, such as what are people's skills, what are people's backgrounds, there are ways to change the algorithm towards that. We didn't do it in this project, but one thing that I've done after this project is looking at the chat history data and seeing when conversations diverge. So there are ways to use NLP to figure out what conversations are good to intermix. Maybe this group is talking about something and this other group also mentioned it. Would it be good for these people to talk or not? Another factor that I found just by reading the chat logs was that people had very different reactions to new members. Sometimes they were very welcoming and that helped the person integrate really quickly. And sometimes they were very dismissive. So that is another kind of metadata that can help figure out when you want to do this versus not.
Oh, I'm sorry. Bring over there.
So just out of curiosity, I see that most of your design for collective action revolved around more systematic and engineering type design work. I was wondering if you plan on taking the same topics of democracy and extending it into more also user interface and like what you were mentioning, that it mattered what the introduction of people into the Slack group would mean. So I was just curious your thoughts on and your research if you'd be exploring in that area as well.
So do you mean in the design of an interface or in the design of a social process?
I suppose either ones. Or anything that is not so much just the systematic and engineering aspects of it.
So a lot of my work that comes out of ethnographic co-design is less of an engineering perspective and more of a developing concepts through working with people who are trying to achieve a goal. I think DYNAMO is more heavily in that space. Some of the more recent work that I'm doing with Twitter is also in that space. We've held a workshop where we brought people together trying to think about what values would you put into a codes of conduct as one way of kickstarting a discussion about democratic values. But yeah, I'm interested in doing more of that work.
Thank you. That was really interesting. I was trying to think about how you could apply it in face-to-face settings, because it seems some of what you're talking about, as you mentioned at the beginning, comes out of organizational behavior research. So some of those tools are often used by trainers for group discussion, say in this room. You might take people and divide them into groups randomly and then rotate somebody, and your discussion of how that could be more effective sounded really good. With the DYNAMO too, setting a deadline and saying, all right, here's the task, and by a certain time you have to start working on finalizing the task, and then some guidelines for the output, whether, as you said, there's an opportunity to revise it or dissent from it or whatever. So I'm just curious a bit, did some of this initial thinking come out of earlier OB kind of work on face-to-face and group interaction and decision-making?
Yeah, a lot of the literature that I build on comes out of organizational behavior from face-to-face organizations, from social movement literature, from communication theory. I think some things that differentiate it is that here we're working with large scales. So something like the specific way that HIVE moves people gets more and more important if you have, instead of the people in this room, you have 100 people or you have 1,000 people or even more. And so those are the specific kinds of places where these interventions become more important. Another example is with DYNAMO. A lot of the things that we had to do were because people couldn't meet face-to-face. If people could meet face-to-face, then we wouldn't need to set a deadline, because they could have a meeting and then everyone would be anxious to leave, so they'd just agree on something, or agree that by the end of this meeting we're going to decide. And so I think that I build a lot of that literature, but I also look at the specific ways that online collaboration is different and maybe harder or easier in certain ways, and how can we design for that.
We have an online question. Thanks for your talk. You mentioned running Twitter as a co-op. How would this work given how some unnamed communities with internal voting moderation have descended into chaos? And then basically, do these work at gigantic scale?
That is a very good question. Thank you. I don't know how to run Twitter as a co-op. I don't think anyone does. But there are models for, so what people mean when they talk about Twitter as a co-op is they're building off of models that exist for running organizations or companies as co-ops. And the way that that usually works is that the workers of a company will have shared ownership, and then they'll be able to vote on who's going to be CEO. There are problems with that model. For instance, after 20 years, that you will have new workers, and then you'll have to rethink how to do this. But some of the models that people have thought about, and there's a lot of space here to figure out how exactly to do this, are based on models of co-ownership, where you would have different kinds of voting rights and ownership rights, and users would have different ones, and workers and engineers would have different ones, and then they would collectively govern the system somehow. Now, this is really, really complicated, especially since Twitter is an international system, and you have people from very different parts of the world in different contexts all working on it. But I think part of what people are talking about when they say buy Twitter is also that they want to have more power in what these systems do. And I think that's the heart of it. I think that they want to be able to have some say in what the security settings are or the privacy settings are. And there are different ways for them to have that more power, even if it doesn't necessarily end in co-ownership of the whole platform.
I have a question about convergence in the context of HIVE. So in addition to the alpha parameter, it seems like there are quite a few other parameters, number of people per group, in fact, number of rounds. And I'm wondering, what are ways in which you can think about, hey, the entire process is converging towards some goal, some target. How do you figure out that you've reached the point of diminishing returns potentially in that case?
Thanks
and perhaps that depends on whether you have 100 people, 1,000 people, 100,000 people, right? And many parameters. So I understand that's probably going to be dependent on a particular social context, situation, and the problem we're trying to solve. But nonetheless, the question of convergence seems to be a common one.
Yeah, thanks for asking that. It's definitely very context dependent. In this specific case, one thing that I didn't mention was that these edges don't keep just increasing, because it's impossible for you to be really familiar with 100 other people. So as you're talking to new people, you're going to diminish some of your older ties. And the way that we did this in practice was that every day there's a diminishing factor on all of the edges. But the specific way that this happens, how much should you diminish, how much should you increase, all of this was based on our prototypes. So we saw, after 2 days of talking to a new person, it doesn't seem like people are engaging with the older ideas anymore. So a lot of it was just based on trying it out in the real world and finding one configuration that works. And there's a lot more space to do more research in that area. For instance, the reason we chose teams of 3 to 4 was that in our prototypes, we found that since people were using text chat, if you got more than 4 people in a room, it got really difficult for people to talk. The alternative was to use video chat software, but then the people who we were working with wouldn't want to use that. They wanted to remain anonymous, and text chat was just a lot more accessible. And so there are these things that factor into how you design a specific kind of software to study a specific kind of question. And yes, it opens up a ton of more questions.
All right, I think that's it. If we don't have any more questions, thank you so much, Niloufar, for joining us today.
Thank you for having me.